Today's topic is Rust. This will be fun. I always like to start at the official documentation, official homepage when I'm learning something. So there's a book, there is a Rustlings course, cool, and then Rust by example. I have a feeling this is where I'm going to spend a lot of my time because this is typically how I like to learn a lot of things. I have a specific thing that I want to do, and I'm trying to do it with some new framework or new language. In this case, the thing that I'm going to want to do is build a CLI tool that can clone a Git repo, do an npm install. It can basically run system commands inside the CLI tool, and it has a few options that you can pass into it. So that's going to be the thing that I want to build with it. So I'm probably going to be just looking at a lot of existing examples and then just going from there. If I were tasked with using Rust at my job, I probably would slow down. I would probably slow down. I'd read the book. I'd do a course. But right now, I'm trying to do it live in front of a bunch of people. So I'm going to do my best to learn just enough to get the thing working that I want working. Yeah, and then learn X and Y minutes. We've looked at this a lot when we've been looking at other programming languages. This site is cool because it just has a bunch of programming languages. And then you can see at a high level what the language looks like. So we're going to see right now, this is our first introduction to Rust. Comments, they're the same, like C-style comments. We're used to this. Cool. Triple slashes, fascinating. Built-in documentation that can have markdown in it. That's cool. That's really cool. And then we have the function keyword that defines a method. We have our parameters to the function, which are typed. It looks like we're going to be dealing with integers. So that I'm guessing this is like an int32. And then I'm guessing this is like a float 64-bit float. And then we can define our return type with the arrow here. And then it has implicit returns built in. That's fascinating. So if you use arrow functions in JavaScript without the curly braces, that's an implicit return. And apparently you can do a similar thing here. So it's just like the last expression of a function is the return value. Is that what they're saying? But already you can see my learning process. We haven't even looked at their docs. I'm just literally looking at the source code and all right, what can I learn from this? What is this telling me about the language? We're getting a little ahead of ourselves. Let's actually go through their official documentation a little bit. I think we're also trying to answer the question of what is it? I guess we could start with the Rust book. Read the intro to what the thing even is. And I'm gonna rephrase this in my own words to make sure that I understand what this book is saying. So the first thing, the Rust programming language helps you write faster, more reliable software. I don't know how I can rephrase that. That's pretty straightforward. Okay, I guess I have to accept that is what it's going to let us do. High-level ergonomics and low-level control are often at odds in programming language design. Rust challenges that conflict. To me, this is saying Rust gives low-level control. And what we mean by low-level control is systems programming, native programming, bare metal. Basically, the code we're writing is very, very close to the metal, very close to the CPU, the actual hardware that it's running on. And so it gives the ability to do all of these things and so what they mean by high-level ergonomics is, to me, I read that as developer experience in a similar style to high-level languages. So think Java, C#, even JavaScript, in that a lot of times those languages kind of hide the details from you at the cost of performance. But what we're reading here is that we can get that without the cost of performance. Through balancing powerful technical capacity and great developer experience, Rust gives you the option to control low-level details without all the hassle traditionally associated with such control. Yeah, so this is really just less hassle than traditional low-level programming languages. Is there anything else on this page? Yeah. Okay, so here's some other stuff we're learning about the dependency manager. So here we'll say the dependency manager is called Cargo. So in the Node.js world, we use npm to manage our dependencies. In this case, they use Cargo. And it's a combined dependency manager and build tool. Makes adding, compiling, and managing dependencies painless. Yeah, so if you're familiar with npm installing something in the Node.js world, Cargo is going to be a similar thing here where we can grab an open source package that has some functionality that we want to add. This is one thing that I had heard about Rust is they have a built-in formatting tool so that everyone uses the same format in their source code. In JavaScript, there are so many opinions about should you use semicolons? Should you use single quotes or double quotes? As far as I know, Rust format has some sensible defaults here. Yes, we don't spend 3 hours working on our ESLint config. Rust is for people who crave speed and stability in a language. By speed, we mean both how quickly Rust code can run and the speed at which Rust lets you write programs. That's a good distinction to make. Speed of developer experience, how fast can I write a program? And then speed of running code. So after I run my code, how fast will it run? The Rust lang hopes to support many other uses as well. Those mentioned here are merely some of the biggest stakeholders. Overall, Rust's greatest ambition is to eliminate the trade-offs that programmers have accepted for decades by providing safety and productivity, speed, and ergonomics. This is a good summary of why would we use it? This is from the Rust book. Okay, so we figured out like what it is, what it can do. I do just want to get started. I want to install Rust on my machine. I want to get the VS Code extension. I want to run a hello world. So let's get this going. I need to download Rust up. I'm just going to trust that I can run this command and not run into any issues. They'll be added here. Cool, this is interesting. It's going to put it in my home directory, so it looks like I won't have to have any like super user permissions or anything like that. It's going to be added to my path. Let's go. Rust is installed. To get started, you may need to restart your current shell. Let's see. Are we in? Toolchain management with Rust up. Do we have Rust up? We do. We've installed it. Good to go. I want to do a hello world. Show me a hello world. Okay, so here's the Rust hello world. Let's just copy paste this, and then from the command line, we can compile it. We're inside the hello world folder. I'm going to make sure that I have the VS Code extension for Rust. I see. This includes multiple extensions. This includes Rust Analyzer, crates, and Rust syntax. So if I install this, I'm going to get 3 extensions, which are all the extensions I need for working with Rust. So this says create a hello.rs. My JavaScript tendencies want me to call this index.rs. I don't know if that's going to be allowed, but I'm going to call this index.rs. Do I need to call it main? They're calling it hello here. Is it going to yell at me? We're going to see. Look, here's the other aspect of like my learning style is try it and see, right? If I don't try it, I won't know that that's something that I can or cannot do. So here we go. I've got this index.rs. I'm going to run the Rust compiler on it. That was fast. And then that spits out a binary. And now if I run it, it says hello world. Look at me. I'm a Rust developer. I can do it. That's easy. That's super easy. People are telling me I should learn about cargo, though, because I'm guessing cargo is what you want to give you a basic project, probably with some like sensible defaults and stuff like that. Learn to create a library, and then they have cargo. Let's look at cargo. Cargo is the official Rust package management tool, dependency management and integration. To create a new Rust project, call it that. So here we go. We're going to run cargo new, and then we're going to call it create express API. Everything's just so fast. So that created the folder, and then let's see what we get. We've got our cargo.toml. So our packages have a name, a version, and then an edition, and we can learn more about it here. I would guess that this toml file is synonymous with like our package.json in the node.js world. So this kind of describes our project, its version, and then it's going to list any dependencies we install here as well. Okay, for example, suppose our program wants to have a great CLI. You can find lots of great packages on crates.io, and one of the popular choices is clap. So we're probably going to be using this to create our CLI tool. A simple to use, efficient, and full-featured command line argument parser. Yeah, so to show an example of what we're going to be recreating is it's a really simple command that basically just has 2 command line flags. You do -d to specify what folder you want to clone this repo into, and then you do -t if you want it to use the TypeScript template. That's it. This is what we're building. I honestly don't think I'm going to have to get into too much of the complexities of Rust to get a command like this working, but that's what I need. I need to be able to parse these 2 command line arguments. And so they're telling me that clap is used for that. And here's the other thing. So like now that I'm getting into the thing that I want to do with Rust, I might even be looking at the clap documentation and then referring back to Rust docs if I need to. But in the meantime, kind of just figuring things out. Yeah, this doesn't look that scary. For a second, it looked scary, but then I calmed myself and reminded myself that we're learning Rust. So yeah, this isn't that scary. So yeah, let's try to install clap as a dependency. How are we going to do that? What is the command line thing I can do to add a dependency? They didn't tell me that, but this seems right. It feels like I've seen someone do this before. Cool. And that is like an npm install, and it should automatically add it to my dependencies. Cool. At this point, we figured out how to create our own little package here. Honestly, let's take a step back and let me get a hello world test going, because I want to make sure I know how to write tests, and then we'll jump into clap. What I would want to do is, instead of printline hello world, maybe I have a function that's like greet, and it returns hello world. And then when we printline here, we want to call greet like this. And so I would write a test to make sure that greet returns hello world. Oh, and then I have to define my return type. I need to say that this is a string, but what's the string type? I have no idea. I'm gonna look at learn x and y minutes, string literals, and string. Chat is very helpful. We have all the Rust people in the chat right now. I guess that's the other thing is most people don't have a chat filled with a bunch of helpers when they're learning something. Oh, semicolon removes the implicit return. Okay. String found, expected string. Okay, so I can just do a string? All right, and then what's this complaint about? All right, this tells me I need to take a step back. I need to learn how do I return a string from a function in Rust before I can even learn how to test and before I can even learn how to do. I got a little ahead of myself. We have so much more to learn. But our end goal is we want to create a command line tool that works like this. It's a very basic command. Basically, we're going to need to write Rust code that reads in the info that the user passed as command line flags. It'll then need to do a git clone. It'll need to do system commands to cd into that folder and npm install. And that's about it. We're going to figure out how to do that with clap, which is a crate that automatically does like command line parsing for us. So here we go. Define on my CLI in main.rs. Let's just take their example codes and see what we get. To run it, I guess we would do cargo run. And then that says we're missing the name. When I do cargo run, name, my name. Do I have to do this? Yeah, okay, so cargo run like compiles it and runs it all in one go, and then we're able to pass our command line flags in like that. If we examine the code, this is where we're going to define our command line arguments. And so the arguments that I want are directory name. At this point, we're just going to print out, we'll create directory, and then args.directory should be it. That. So if I do this, it should yell at me that says you didn't specify a directory. Awesome. I'm curious, though, does it say what the... oh, awesome. It also automatically does the short version, too. Because you can see in my docs, I allow them to just do -d. Well, that's awesome. It does that by default. Cool. So if I pass in -d test, we'll create directory test. Look at me. I'm doing it. Okay, so we want directory, and then we also want TypeScript. The other thing I want is you'll notice for -t, there's no argument passed onto it. So I need to figure out how do we specify a command line argument that has no value on it. Maybe it's a Boolean? Yeah, like this. We don't want it to be kill all humans. We want it to be TypeScript. And we want it to have a short and a long. And then we'll say with TypeScript. And then we'll do args.TypeScript. See what we get. Yeah, and it doesn't complain. That's what we want. Easy enough. So if we don't pass in -t, it just says TypeScript is false. But if we add -t to there, TypeScript is true. We're almost done. This is our entire thing. At this point, we want to clone a Git repo, though. So let's search for a crate that allows for Git cloning. I guess I don't even need necessarily a separate package. It honestly might be more interesting for me to figure out how do I run system commands, because that's potentially useful outside of just cloning a Git repo, because I'm also going to need that because I want to be able to run npm install and then like git clone. So I think it would be better to figure out how can I run a system level command with Rust. I'm going to try to find some examples. If it looks easy enough, I'm just going to do it. If not, we'll look for a package like git2 or like bossy or something like that. How do I invoke a system command? Yeah, this seems fine. I don't have to install anything for it. This is just built in. So in the node.js world, we have exec and like child process. Let's try it. Let's do this. We're going to have a repo URL. It's going to be this. And if args.typescript is true, we're going to override that to be the one with TypeScript. And we run into a compiler because you can use if as an expression. So when assigning repo URL, you can do if after the equal and do implicit returns in the body. Whoa. Okay. This is amazing. Oh, and then I don't need the parentheses. Yeah, and then at this point, do I not need toString? Because I should be able to just use it. And then I get rid of the semicolons too. Yeah, better. So you saw that before it couldn't infer the return type. It's because I had the semicolons, which got rid of the implicit return. And then now I don't have toString, so it's just an str. Let's see if I can use that with the command runner here. Because at this point, I want to create a git command. This. Like that. There we go. Yes, it did it. It created the test directory. Cool. I can use args instead of arg to pass an array. I think I'll do that. All right, let's look at their docs on output. Ultimately, I'm trying to just take the standard out of this command and output it to standard out. if I use spawn, it'll inherit by default. The only thing I worry about with spawn is how can I make sure that the code waits until spawn is finished before it does the next thing. So because it returns result, you can match on it. So if we were to do, instead of doing output, if we do spawn, what's the return value here? Result child error. And then I think what you're saying is if we match on it, it'll wait for it. It's blocking by default. Let's see. Yeah, so we did see the output here. But we do need an expect. Cool. Much better. Okay, so now if we remove that example folder, it should work. And we should see the output of git clone. Yeah, so, oh, well, here's the thing. It didn't block. It didn't block. See, now all of this is running. Yeah, it didn't block. And that just spit it out to the standard output. We need to wait for it. Yeah, so result is a child now. Oh, there we go. That was the issue. So it was like a tuple with child error, and I didn't know how to access that. But now that I have expect, it's not a tuple anymore. Maybe tuple is the wrong word. But now that I have expect, it's just a child, and child does have a wait property. Cannot mutate immutable variable result. Cannot borrow result, which is mutable. Consider changing this to mute. Thank you, compiler. All right, now what else? The result may be an error variant which should be handled. The dirty way is just unwrap the result that makes the program panic. Better way is to match on it. Okay. I need to look up matching because I have no idea what that is. But here's the thing. If it failed, the next bit of code here is cd into clone directory and npm install. If it failed, I don't want to do these two things. So I think I need a matcher, so that way if it fails, just output it failed. But if it didn't fail, then run these next commands. Oh, okay, here we go. Here's the matching. If I'm understanding what's happening here, so if it ran okay, we're going to get an exit status. That exit status is going to be in wait result. And then down here, we could say if wait result is 0, do all this stuff. Else finish with error. But I need to handle this. Or use .expect. We were using .expect, but I feel like it got rid of the exit status, didn't it? And then this is an exit status. That's what I want. Wait clone result is what I'll call it. Wait result.success. Okay, but I think this should do it. So now, finished with error. So yeah, now it went here because it knew that it wasn't successful. We're cloning the repo. After we clone the repo, we want to cd into that directory and run an npm install. So let's do it all over again. Yeah, now the command is npm. Oh, you can just do .directory on a command? Current directory? Oh, sets the working directory. This is cool too, because if we set the directory to args.directory, npm arg install. Yeah, let's see if this works. Failed to install dependencies. We'll do the same thing if this is a success. Okay. Moment of truth. Here we go. So this should clone the repo, do an npm install, and be done with it. So clones it, npm installs it. We're on the way. And then now it works. The cloned repo, the tests run, the thing starts up. Cool. Okay, at this point, I would just like to clean up the code. It's technically working, but here are some things that I want to clean up. We have strings that are duplicated in multiple places. I want to create some kind of data structure where I can say like error messages dot clone error or error messages dot install error and then put that in there. And then we'll also clean up the other messages that we output so it's a bit nicer. But yeah, let's look into what Lame is mentioning, which is essentially instead of spawning, waiting, and then checking the status, they're mentioning that we can just get the status directly back from command. Status. Executes a command as a child process waiting for it to finish and collect its status. By default, standard in, standard out, and standard are inherited from the parent. Beautiful. This is exactly what we want to do. So instead of spawn, we just say status. We don't need to do this. This will be clone result. Doesn't have to be mutable anymore. And now we can just check it right here. That got rid of like 2 lines of code. I like that. And then we can do the same thing here. Let install result dot status do this. Cool. Thank you for that, Lame. We'll see if it works, but this looks good. Yeah, this is what I was asking for more so. Yeah, I don't know if I want another package. I kind of just want to know, yeah, how do I create a map of string to string? And I guess an enum is probably the way to go. Let's see. Enum error messages. Yeah, this is really what I'm looking for, because then I have my clone error, and then I also want my install error. And then failed to install dependencies. Now let's use this. So we have our error messages here, and then down here, this is going to be error messages dot clone error. This is really ugly. Is it going to be like this? That's really ugly. Do I really have to do that? Error messages clone message dot message. That's what I want. That's a little nicer. Yeah, that's a little nicer. The idiomatic version is to use a const variable here. I guess that's kind of what I was asking, is like, I guess I would just have a bunch of consts, which are the error messages, and then reference those variables where I need them. Here's the one thing we haven't done, is define things in a separate file and import them. I think I want to learn how to do that, because it would be cool if I had a namespace called error messages that had my const inside of it, and then reference it that way. That would make the code simpler right here. I wouldn't have to do as str. Here we go. Let's do something like error messages.rs. All right. We've got error messages. It has 2 error messages inside of it. Now I want to import it. Is it just a file path? It's a module. Like that. And then it's like, yo, you can't have a dash, so I should name it with an underscore. And then, do I just access it? Public const. Okay, there's a bunch of new stuff to me here. Like, I haven't learned about like the visibility stuff in Rust yet, but that makes it publicly available. This is, I guess, is kind of like the export keyword in the node.js world. But by making it public, we now have access to it outside the module. And then we use like this. Yeah. Wow. That is some nice code. I like that. Okay. I think one of the other things I want to do is in the cloned repo, I want to get rid of the Git folder. Yeah, so because we're using git clone, it has the .git folder. But when we clone this down for somebody, I don't want it to have the Git folder. I want it to have like no Git history, nothing associated with Git unless they actually want it. So the other thing I'll do after the npm install is remove the .git folder. I can remove the folder directly in Rust. Let's do that, because right now we're using this command thingy. Let's use some Rust built in for removing a directory. Remove directory. Here we go. We need to use fs. Can we put an expect? Yeah, we can put an expect on it, and we'll add another error message. So we can do error messages, remove git error, and then we'll reuse that here. Put it over here. Pablo is right. You need to remove git, though. With this, you're removing just the created folder. Good call. Yeah, I messed that up. Yeah, this shouldn't be removing the directory we just created. You're totally right. This needs to remove the .git folder within the directory we just created, which means we probably need like path join. Is there a path join in Rust? Standard path? Cross-platform path manipulation? Create a path, push onto it. This is what we want. So create an empty path. Call this the git path. And then we're going to push the args.directory into it. We're going to borrow it. Are we going to borrow it? Did I say that right? We also want the Git folder inside of there. Why not have args in the from? Oh, good call. Yeah, so start here and then just push.git into it. And then now we want to pass that path in here as operating system string, I'm guessing is what we want. What do I do with result? What can we... Result is nothing? So it's just going to do it, but if it errors out, it'll... Will it exit the program? That's the main issue. Is I don't necessarily want it to exit the program because I still want to try to do an npm install. So maybe we do it after the npm install. You can pattern match over the result. This is what I want, right? Something like this. Yeah, okay. But at the same time, I think I can just do it in line. I don't even need to put it in a variable. Can I do that? Yes, okay. And if it was okay, I just want a no-op. Can I do that? Yes, I can. But if it wasn't okay, we're going to just print the error, remove get error. Oh, and then we have to do this like that. Look at me! I'm learning! I'm learning! And then in here, we put an underscore to say that we're not going to use the value. And then same thing here, we're not even using the error. So both of these should be underscores because that indicates that we're not going to use those values. Okay, to clean this up, if I do let error, it will just give me the returned error and throw away. That's interesting to see because yeah, in this case, I don't want to do anything if it wasn't an error. So the cleaner way is to say if let error. And then if this is it, I like this better than this because this was I was just doing a no-op for OK here. Yeah, I guess that's one thing is how do we set the status code of the run if it's not a success status code? But a lot of terminals will tell you if your previous command was a failure. All right, we have 2 votes for process exit. Let's do that. And I can never remember, is 0 a successful status? And then like anything beyond that isn't? Is that accurate? 0 is success. Okay, 1 is error. Cool. Yeah, and then in the other cases, it's still technically successful because it cloned the repo. At that point, you can kind of just do whatever you want. All right, let me go to my existing command and then get any other messages that I'm outputting. Let's see. Okay, this is something I think I do want to do though, is output to the terminal with color. So in the Node.js world, we have a module called chalk, which lets you set like the print line color. All right, let's search for a crate that lets us output with colors. Term color, a simple cross-platform library for adding color text to a terminal. The most simple way to add colors in your terminal. Let's look at these 2. We'll pick between the 2. Example, using standard stream. Yeah, that all looks too complicated. This looks way better. Yeah, we're gonna use colored. Cargo add colored. All right, so we have colored now. We use it. Now that we install that, we should be able to use it. So this augments all of our strings. So now we can do print line done. But if we do .cyan, I have to pass it as an arg now. Do we have cyan? Yeah, we do have cyan. Nice. Cool. Okay. I'm curious why I didn't have to put an ampersand in front of args.directory, but let's see if it works. Nice. That's awesome. Honestly, I kind of want to output the errors in red. And then we also should be outputting an error here. So if we weren't able to clone, this is a clone error. But this is the Rust code that I wrote today. I'm happy with it. We learned quite a bit, even with code this simple. Let's give a rundown. And also, let's validate some of the assumptions and things that I had about Rust at the beginning. Because before going into it, obviously, I had heard of Rust before. I've worked with C++ and C when I was in university. That's really my only exposure to low-level languages. And then I worked with C# professionally for like 3 years. But that's not a low-level language like this. We confirmed it's a low-level programming language. It doesn't have a runtime. It compiles natively. We learned about the memory safety. We learned about like borrowing and stuff like that. And so these memory errors are caught at compile time. Other low-level languages typically require like manual memory management, things like malloc and whatever the reverse of that is to allocate memory and unallocate memory. And other languages also have garbage collectors. Rust does not have a garbage collector. Basically, Rust doesn't have any of those things. It just, depending on how you use the variables, is how it determines if it should remove that variable from memory. Rust has opt-in garbage collector if you really need it. So like reference counting. Yeah, that's my only exposure to like somewhat automated memory management in like C and C++, or in C++ specifically with like shared pointer and auto pointer. And I guess Rust has something similar. All this other stuff, we learned about it. It's low level. It lets you write faster, more reliable software. I think this is the main thing that Rust, one of Rust's main selling points is it's a low level programming language, but it lets you code things in a similar style to higher level programming languages like JavaScript or C# or Java. You have a lot of the niceties that you have in those languages, but with low level programming. All of the ways to learn are like from the community itself. If I just start taking some notes here on my like overall impressions, the docs are amazing. Everything we wanted to do today, except for one example we found on Stack Overflow, but almost every other example we found in the docs. They had good examples of how to do everything that we wanted to do. Docs were fantastic. I'll say the crates we needed existed. So we found a crate for creating like the colors in the console. We found a crate for handling command line arguments, and those worked great. So yeah, in terms of what we wanted to do, it existed in the ecosystem. I'll say the community is nice. We had Rustations in the chat today, just helping us out when we ran across things. Yeah, and I think that's the other thing is the compiler errors are really good, like really good. Like they tell you exactly what you need for the most part. I think there were 2 occurrences where the compile error wasn't clear, but the fix was actually pretty clear. I will say, like, the code wasn't too crazy. I think one of the things that a lot of people that work in higher level programming languages, like I do on a daily basis, when you come across some Rust code, or any other like low level code, it just at first glance it looks like, what am I looking at? But for me, I think I was at least able to get used to the syntax pretty quickly. I think I'm still having an issue like remembering the syntax when I'm trying to do like pattern matching, like this and like this. But overall, for the simple stuff that I was doing, the syntax was fine. There's nothing too crazy, nothing too different from what I'm used to in JavaScript, which is like a C-style language. Yeah, I will say that's one thing that took me by surprise is like, at least for the simple stuff I wanted to do, the code wasn't crazy. Oh yeah, setup and tooling. Cargo is full featured. We have our project setup, linting, formatting. It's all built in. I didn't have to do anything extra. So once you've installed Rust, you have access to Cargo, and the fact that it has project generation was super cool. Easy to add packages. Yeah, no complaints around there. And it's blazingly fast. I mean, well, obviously we're not doing anything that would need to be super, super fast, but the code compiled really fast. The code ran really fast. I didn't do any sort of benchmarking, so I can't speak to how fast it was. But yeah. Anything else I want to mention? Yeah, this ownership concept I think is going to take some getting used to, but it seems cool. It seems like an interesting concept that once you get it, your memory management woes are gone. Like once you understand borrowing, you're good to go. Good to go. Yeah, I think that's everything. Anybody in the chat that was new to Rust as well, let me know, what were your impressions of it? Did you have the same impressions that I did? Obviously, I think I made it easier because I'm taking all of my prior knowledge and applying that to trying to learn this thing. But yeah. Yeah, and thank you, Lame. Thank you for your help earlier, too. Says, thanks for checking out Rust. I'm glad you had a good impression. Yeah. All right. I think that's it for today. So if you want to see all my notes, I think I'll go ahead and push them up. Yeah, thanks for hanging out, everybody. We're going to go on a raid after this, so definitely stick around. But I'm going to push this code up to the Try-Day Friday repo, so you can see all the codes I wrote and the notes that I took. So this is over on GitHub/codinggarden/Try-Day Friday. And then we have today's notes and codes. But yeah, take care. This has been super fun. I really do appreciate everybody that was helping out and all that good stuff.